Hello, this is Nancy Stolick. I'm the Education Manager at Friends of the Rappahannock. Today we're going to talk about our stormwater sediment filter design brief. But first, a little bit about Friends of the Rappahannock. We do three things. We advocate for the river, so we stick up for the river. We restore the river, so we restore oyster beds and riparian buffers along the river. And we do education. And all of this is to make sure we stay the voice and active force for a scenic and healthy Rappahannock River. Okay, so today, think about the river near you, or the Rappahannock River, and think about what you think the top pollutants are in the river. So kind of let that mull around in your head for a while. And in the next slide, I'm going to have out of order the top 4 pollutants. So look at these and decide what you think they mean. They're not in order again. So this you can tell it's trash, right? So litter is a problem. This, you can see it's a little slick. It's oil slick on the top, so that's oil. This is algae, but the actual pollutant in here is extra nutrients. That would be fertilizer or manure from farm animals. When it gets into the water, it causes algae to grow in a huge amount. And that's a problem because when the algae dies and decomposes, it sucks oxygen out of the water. So that's a problem. And then this is the last one that we're showing on this slide. Again, they're out of order. This is sediment. Sediment is a problem. That's dirt suspended through the water column, because when there's this much dirt in the water, light can't get down through. When light can't get down through to the plants that live there, those plants, just like the plants on land, can't photosynthesize to produce their own food, and they can't give the byproduct of photosynthesis, which is oxygen. So these are the top 4 out of order, and you can tell what their problems are for all 4 of them. So think about what you think the very top pollutant is in the Rappahannock River. Just give a guess. And then we'll show you them in order in the next slide. All right, so here they are in order. The top pollutant is sediment. Usually no one guesses that. They think it's litter because that's the one that gets talked about the most. But sediment is the #1 pollutant in the Rappahannock River, and extra nutrients is the second. Both of these cause low levels of oxygen. Just like animals on the land, we need large amounts of oxygen. The animals that live in the water need large amounts of oxygen too. And so when we have too much sediment and too much nutrients causing low levels of oxygen, that causes a lot of things to die. So this is #1, sediment, #2, extra nutrients, and oil and trash, those tie for #3. Today's challenge has to do with #1, sediment. There's a couple of ways that pollutants enter into any water source, and we basically call them point and non-point source pollution. Point solution, you can basically point at it. It's very obvious if you test this water and there's a problem with the water in one of the water quality measures, you're going to suspect what's coming out of this pipe. So that's point solution. But usually what happens is non-source pollution. Different things from various areas across the watershed flow over the land and end up in the water where they mix. So when you do the testing for water quality measures, you have to really do some thinking to tell which is causing the problem. This is showing something that could be coming from a factory, probably oil and trash coming from a neighborhood. Farms could have sediment and extra nutrients, and of course this plowed field would be putting sediment into the water. Today we're talking about sediment, the top pollutant in the river, but isn't it better to talk about how we could prevent sediment from going into the river rather than seeing how we can deal with it after it's already there? Prevention is usually the best thing to do. And so here are some of the ways that Virginia and other parts of the country and the world are handling sediment to make sure it stays on the land where it should be. These are called best management practices. The first one, take a look at this picture. You see some cows in here and they're in a pasture and there's a stream here. Well, if you can see, this is a fence. These cows are being fenced into their pasture and out of the water. So this is just a barrier, making sure that these animals do not go into the stream and go to the bathroom in the stream, which would add to nutrient load. And also as they walk in and out of the stream, their hooves fluff up dirt there, and that has extra sediment load in the water. So this fence is preventing a lot. The second picture is showing an example of no-till farming, where you disturb the dirt as little as possible where you farm. Last year's crops are, they stay in here, they're not scraped off, so they're holding all of the dirt down where it is. And then when they plant this year's crop, they do a small furrow just enough to get the seed in. So this is no-till farming, which disturbs the soil very little. This is showing construction barriers, and this is a law where construction, road construction or new construction is being planned. They have to put up these barriers so that in the case of a large amount of rain or a storm event, you can catch the sediment before it goes into any storm drains. And this is leaving a riparian border or a border of trees along a waterway. So no matter what is on either side of this riparian border that surrounds this stream, it's going to prevent whatever would be on either side to go into the stream. If it's a field like this, it will prevent the extra nutrients from going in. Or it could be parking lots on either side, and it would prevent a lot of trash from going into the river. It would be caught up in trees before them. The other thing that the tree is providing is shade. Cooler water holds more oxygen. So shade might seem like just a simple thing, and it is, but it's very important for how healthy water is. Cooler water holds more oxygen for all the living things in the water. So those are preventative measures to keep sediment where they belong. Underground, we have two main kinds of piping in most areas. One takes care of all the wastewater that's in from a household. So it would be from flushing toilets, any water running from the sink, any dishwashers, showers, all of that would go to a pipe and to a treatment facility. This experiment is not talking about this water. That water gets treated. Today we're going to be talking about storm drains. So when it rains and the storm collects down into our storm drains or ditches, that water goes untreated directly into any local waterway. So that's the type of water that we're going to be talking about today. We are usually looking at this. We see a curb and a storm drain here, and this is what we see from the top of the roadway. So any extra water flows over the land or over the hard surfaces and down into here where it goes into the pipe. If water lands on grassy surfaces or forested surfaces, that's called pervious. It can pretty much soak in unless it's a flooding situation. But if rain lands on this area, that's an impervious surface, water can't soak in there, so it has to go down these drains. Down under the ground, which is what you don't see usually, is a large concrete box. Sometimes there's a structure in there that will catch some of the small debris, but if there's any sediment in the water, that's going to go straight out into the local waterway from this pipe. So you can see how it would be important to have some kind of a measure, some kind of a filter that would stop the sediment from going into the local waterway, as that is our top pollutant. Our experiment that has to do with this is going to have you experiment with water that's very turbid or has a lot of cloudiness, and it will see how you can build a filter that will lower the turbidity or cloudiness of a sample that you have. You might have supplies already given to you, but there's things that you can use in your own home that you can collect, just a few, that will help you do an experiment to see how you can lower turbidity in a water sample.